This is the Gifted and Talented Summer Camp, a camp with students of gifted minds selected to take part in creating a speech or talk. But what makes us different from any other average student or students with cognitive disabilities? The answer is in our brain. Have you ever wondered how we learn, process, and comprehend things? First, throughout this talk, I will be talking about the brain structure and the learning process. Second, the comparison in the minds of the gifted, average, and in the minds of the people with cognitive disabilities. And lastly, how we can keep our brains sharp. First, the brain has many different cells, but the two main types used are the nerve cells, also known as neurons, and second, the glial cells. The third substance is the myelin sheath, but we'll touch on that later. So let's start with the neurons. The neuron has three main basic parts, and that is the axon, the cell body, and the dendrites. In this simple drawing, you can see the axon, which is as the stem, the cell body is the flower, and the dendrites, which are as leaves that are constantly seeking for new information. And upon finding that new information, the message needs to be transmitted to other neurons. So the message will travel down the axon to the dendrites of the next neuron, which travels down the axon, and so on. Something to notice here is that these neurons never actually touch, and they have to travel through this little space called the synapse. This process is electrochemical, meaning the electricity takes place inside the neuron when it's firing out the signal, and chemical when it's traveling from neuron to neuron. And this chemical is called the neurotransmitter. As the number of connections increase, the brain strengthens the synapses and dendrites. And as before, this whole chain of connections is called the neural network. When you're making connections and you're learning, it's from neurons that are going from the repetition of firing these specific signals and getting practice. The more repetition you have, the more developed that neuron will be. For example, addition. This is a skill that's practiced over and over in elementary school and throughout secondary school as well. By the time we're in high school, I hope we've nailed single-digit addition, and again, hopefully we've become quicker at adding more digits together. And our faster pace in thinking with these skills or other daily tasks such as brushing your hair or brushing your teeth are because of, as stated before, the repetition of firing these signals through the same neural pathways. When we were little, we had to think about the little things such as every stroke to brush out your tangles or trying to get a better grip on your silverware. And this was because it was your first time trying it out. But as we do it more often, our actions become easier to accomplish and more smooth, just as our neurons develop more fluent connections. The second is the glial cell. And these are like caregivers. They're the support. They provide nutrients for the neuron. And one glial cell in particular that's very important is the astrocyte, which is the shaded cell right here. And they're responsible for supplying most of the nutrients and altering the space between cells and overall regulating the neural communications. And these glia, unlike other neurons, can all reproduce. So the more you use your neurons, the more glia that will be reproduced to suffice that neuron's needs. And the third substance is the myelin sheath. And this coats the axon, as you can see, and they're made of fatty proteins. It helps the signals of the neuron be transmitted more fastly and efficiently. And how we get here, or how the brain develops, is seen with Piaget's stages of development. The first stage is a sensory motor stage. Sensory meaning senses, and this is when you're a baby and you use your basic 5 senses to actually take in knowledge of the objects around you. And the next stage is the pre-operational stage, where you begin to grasp that language and begin to imagine objects in your head, but you still need concrete examples. And by concrete examples, for example, during Chinese New Year, our families and friends actually give each other red pockets, which are these red envelopes, and they have money in them. and my sister received a $100 bill, and she was 6 at the time, so she's still in this pre-operational stage. And my dad jokingly asked if she wanted to trade a $100 bill for 2 $1 bills, and she agreed, because I mean, 2 pieces is better than 1, right? And it wasn't until we made this trip to another city and she discovered the value of the $100 bill is far greater than the 2 $1 bill. And this understanding of value in math is the concrete operation stage. And from around age 11 and up would be the formal operations stage, where we are able to think, and we're able to think theoretically and hypothetically. And the next, the second part would be the comparison between the gifted mind, the average mind, and the mind with cognitive disabilities. And an example of a gifted mind, or actually genius mind, would be Albert Einstein. When scientists studied Albert Einstein's brain and compared it with other normal brains, they saw something that he had an unusual ratio of glial cells to neurons. And glial cells were the nurturers. And this occurred in his parietal lobe, where every neuron he had, there were a significantly larger amount of glial cells. So this is believed to have helped his conceptual and thinking skills. This is just Einstein himself, but he was also part of a pattern that we recently studied today in the MRI scans with other gifted children, that our cortex area, which is in the frontal lobe, is actually smaller than those of average people. And this usually is a sign of underdevelopment, but when they looked deeper, they saw that this section was more dense, and actually the neurons worked more efficiently. And lastly, those with cognitive disabilities. And there are many cases, and it's a diverse, set of disabilities, but some may lack pathways or myelin development in certain parts of the brain that might make it a little bit challenging to grasp certain subjects. And in some cases, there is asynchronous development, where the emotional, intellectual, social, and physical development is actually occurring at different rates. So for example, a child could have a great understanding of mathematical concepts and use very advanced oral vocabulary, but he or she may not be able to actually write that down and may have trouble making friends because those development speeds are changing. And another case is twice exceptional, where the child is in special education as well as gifted. How many people here have watched The Good Doctor or heard of it? A couple. Okay. It's about a doctor who has autism but shows extraordinary skills and ability in his thinking. He's twice exceptional. And lastly, how do we keep our brain sharp? Well, the first thing we can do is actually eat healthy. Everyone says eat healthy, and it's something that even annoys me, but actually when you eat healthy, you have enriched neurons. And this is an impoverished neuron. This is when you don't eat healthy. Or when nutritionists say you shouldn't diet before 15, this is because your neurons won't get enough nutrients. The second thing would be studying. And it's not a pleasant thing to think about, but your brain contains plasticity, meaning it's built for continuous learning. So every time you review that material or study it, this will actually give you more knowledge. And third would be stress levels. And a solution to this would be just finding a hobby or something to do daily, even weekly or monthly, just to relax your mind. Because when you have that feeling of stress, your brain actually releases toxins, and the ones that are especially poisonous are cortisol and adrenaline. And these actually damage your hippocampus, which is used for memory. And a study showed that people under constant stress actually found it harder to learn, focus, and even memorize just the simplest things. And lastly, the attitude to learn. During this camp, our teachers told us that we must have a positive attitude and passion for a topic. Otherwise, we won't be able to talk about it. And this is because when we're not having a positive attitude, it actually tells our brain to turn that learning ability off, and we're not ready to take in that information. So, we've learned the brain structure and learning process, the comparison of different minds, and how to keep our brains in check. Hopefully, you've developed more pathways in your neural networks today. Thank you.